All right, we're going to pick up right where we left off. So in the last stream, we worked on pulling stock split information from one of my data providers, and we wrote some functions to take a list of positions that you might have in a stock, and then make them split adjusted, meaning adjust the number of shares based on the time that you purchased them and how many splits have occurred since then. One thing we didn't do is we didn't add caching to that. The other thing that we have left to do is also adding calculation of dividend returns to your position. So if you purchase a position in a stock and that stock pays you a dividend, we want to be able to calculate the dividend paid for that given position to help us later down the road calculate total return. We added this to our retrofit interface in the last stream. We wrapped this in a service, and we used Slack's retrofit library Ethernet to kind of parse the response. And typically, when I get this data, and in particular this data rarely ever changes or usually doesn't change, obviously once they've declared it and the stock is split. So in that case, when we're getting historical data, we want to cache this essentially forever. So the way that I do that is typically both in memory for speed, but also I save that data in my Firestore database, which is kind of the more durable version of the in-memory database that I have that I use for kind of quick access. So we're going to go ahead and add that. And then we will probably move on to calculating dividend return. So we've done a bunch of streams on caching before, but we're going to go ahead and add this, and we're going to do this in a similar way, or we're going to store this in a similar format that I do for dividends. So let's actually take a look at that. So we have a list of companies paying dividends, or when we get, basically a list of companies paying dividends, we store that in a database. And I will take a look here at how I store that in Firestore here. And you'll see here in dividends, I basically have this kind of prefix where it's essentially the symbol name underscore and then the year that dividends were paid, and then basically in here there's one item called dividends, and then I have both the symbol and the year. So this format has worked out pretty well for me in terms of flexibility in querying. And we're essentially going to go ahead and replicate that, and we're going to have a new collection for history of stock splits. So let's go ahead and do that. And we can borrow a whole bunch of the code or kind of work from it on how we save dividends to make this nice and neat. So we're going to call this Firestore Splits. It's going to be at least a file. We'll split that out to the right, and then let's take a look at dividends. All right. So here in dividends, right, if you see save dividends, you'll see I've taken a list or a symbol, right, and then a list of dividends to save. And I run this in a transaction because I want to save them all at once. And I group the dividends by the year. And then I store those in a collection called dividends. The document ID is the symbol and the year. and then I save that data essentially just in a map, and then it's pretty easy to pull out later. So we're going to go ahead and basically do the exact same thing, but in this case, it's going to be for splits. So let's go ahead and do that. One other thing to note is there's no caching on this, but that's because I do the caching at a different layer here, but it's effectively going to be the same thing here, right? So this is probably a little better. We'll take a look at this for a better fit. So first thing is we're going to call this splits. So this is the cache config for the in-memory cache. And we'll go ahead and add that configuration in a bit. But this is going to be... So this first is going to be cacheable, right? And this is going to be to get the splits string, and we're going to have from year and to year. And again, we're going to do, I've talked about this in previous streams, right? But the Micronaut cacheable annotations do not work with suspension functions right now. There's an open issue for that, but again, it doesn't support it yet. So we essentially have to bridge the gap. And the way that we do that is we use this extension function from the Kotlin coroutines compatibility package, which returns a completable future, which is the primary interface that you'll see used throughout Java for asynchronous programming. And this cacheable interface is actually compatible with that. So we're going to have a function like this that gets the splits. And we are also going to have, similar to like this, we're going to have something that's called cache put, which puts things into the database. This is going to take a list of splits, and we're going to have a name clash here, so we'll need to fix that. And notice this is cache put, meaning that when it saves it, it actually puts it in the cache. So, okay, we got to do a couple things. So we need a class, and I think I typically call these... let's just do this. Splits data. And we'll just put this here for now. So this is going to be split data. This is going to be a list, though, in keeping with our typical interface. The other thing that we're going to need is a key generator. And so because we have multiple things here, multiple arguments here, we need to tell the Micronaut caching framework how to generate a cache key. There's a couple different ways that you can do it. I personally just like doing it this way. And it works pretty well. And in this case, it's a really simple thing to do. You just say, hey, this is the key generator. This is interesting. This may not exactly work the same because we need to include the date here. So I'm going to think about this. I might just say, For now, it's going to be dumb. There's not going to be a ton of splits, so I don't probably need to range bound it with some of the other functions that I have. I do range bound it, but in this case, I'm not going to range bound it because that would make the key generator a pain. So we're just going to kind of skip that and make it easy. So we've got our signature for save and our signature for get. We've got our key generator. Next thing we need to do is we have to add our configuration. And I think there's some sensitive data in my application properties, so I'm going to do this over here, but I will show you what I have added in just a moment here. So there's typically two things that I set that work pretty well for me, and I'll copy those and show you what I do. So in application properties, Micronaut has a way to set the configuration. You can also set the configuration on some of these annotations, right? But the format here, and this is in the documentation, is essentially micronaut.caches.name of your cache. So in this case, I'm calling it splits. So if I say micronaut.caches.splits, I can then configure the cache. So in this case, I'm saying expire after write 365 days. So essentially never expire because it's highly, highly, highly unlikely that my server runs for more than 360 days without being restarted or something like that. And this is basically saying how many items can be in the cache. This is an arbitrarily large number. Again, I don't ever think I'm going to get this high. And so what this effectively does is just say cache this in memory forever. Again, this is a very simple in-memory cache. If the server gets restarted, the cache has to repopulate itself as people use the app. But that's totally fine for now. Later on, I can very easily swap out the in-memory version, which uses caffeine as the cache library for Redis or something else. So not that big a deal. So we're effectively, again, caching this forever or for as long as the server is up. And now we can go ahead and implement both of these methods. So let's start with save, and it's going to be basically the exact same thing. So if it's empty, we're going to return because there's no work to do. Then if we have something, we're going to run a transaction. And actually, that's kind of interesting. I don't use run async transaction. Why is that? Oh, there probably isn't a reason. So, okay, so let's do this. This will introduce another actually interesting thing that I've done. So we're going to say splits.group by, and we're going to group it by, we're going to need some more data in here. So we're effectively going to have the exact same data as the stock split. And again, this is a little duplicative, but I don't mind this because it keeps my data layer from causing problems and leaking out into other modules. So, so I typically do this by the X date, and we're going to get the year from that. So we're grouping the list of splits that we got by year. Then we're going to go for each of those items. And so this is essentially going to give us year and the splits for that year, right? And we are going to say firestore.collection, and we need a splits collection. So let's go ahead and create one of those. This is just constants for me to keep track of the collections that I have. Splits. We're going to create a new document, and that is going to be for the symbol that we have, underscore year, right? Then we're going to set a map of the following. We're going to call this splits to splits, year to year, and symbol to symbol. And then all right, so what's this complaining about? It's probably because it's an asynchronous function. Run async change exit, and then attempts to commit the changes applied. If any document read within a train that unblock other. So this is an async function. Yeah. Oh, that's because I haven't actually written a... Oh no, that's what is being passed. Okay. Oh, do I have to do... So I'd have to use this, right? I haven't actually used this version of the API before. As you can see, I used the other one. There's no collection on this. Transaction dot create set. It's got to be done on a collection, right? Interesting. What the heck is this function? An update builder. API future. Update builder. Create document reference. Oh, okay. All right. Yeah, I'm not a huge fan of this. This API is a little nutty. Given that this exists. So, but actually, I'm actually using this incorrectly then. Executes a given update function and then attempts to commit the changes applied within the transaction. If any document read. Okay, so maybe I'm actually using this API wrong. Let's check this out. Transactions and batched writes. Right, yeah, it uses this document reference stuff. I don't really want to convert to this right now, but that is something that we definitely need to do. Because this is clearly not correct, even though it works. I don't need to pass information out of transactions. Updating data with transactions. Okay. Yeah, you know what? I'm just going to get rid of this and this. And do that. And call it a day. And we'll come back to this and maybe we'll rewrite this. But we don't actually need to do this craziness. So we're going to async and await that as well. I wrote some helper functions or some extension functions to convert the asynchronous version of the Firestore API into like a nice coroutine version. So this async just takes this future, wraps it in what's called a completable promise, and then returns it as a deferred, which is kind of a, you know, the coroutine job. And then I just call await on it, right? Which is the standard function on a deferred in the coroutine world. So that should save it. Then we need to query for it. So we need to do firestore.collection splits. And we need to query for all of the documents. So we're going to say dot where equal to symbol is the symbol. And this is going to be this. And then we need to add stuff for the year. And because I'm not allowing you to pass that information in, we're just going to make it from the current year to like a year a long time ago. So if it's greater than 1900, because we don't have any data before that, less than or equal to the current year. And I think, I don't know if I have year. Oh, local date.now, that's right. So that'll give us basically all the splits for a given symbol that we have. And we want to async and await that. But then we also need to kind of we want to just convert it to a list, right? So the return of this function this isn't super usable, right? So this returns a completable future of query snapshot, which is not what we want. So this is where I write that converter function and I say documents, and then what I typically write is like to Firestore Splits, and I will create an extension function for this. So this is going to be, documents is list of query document snapshot. Firestore Splits, and so then I return a list of Firestore Splits data. And this can be singular. And so we're now going to map the data that we get from Firestore into this object, which is going to be, is that going to be a little strange? No, it should be okay. So the documents that we're going to get are going to have an array in them, and that's really what we care about, or that's really what we're going to convert. Because that's what we stored. So we're going to map each document. And so what does each document look like, right? It's got splits, year, and symbol. So we're really only concerned with what's in splits. So then we're going to do doc.get we're going to get the splits as a list of, what do I do in other cases? List of map of string to any, right? Yeah. I do something like this. Not necessarily the most type safe thing to do, but I am quite sure of what I'm doing in this case. So then we're going to map these into Firestore split data. Item dot symbol as string. Declared date, x date, ratio. This will be as double, from factor and to factor. From factor, to factor. Okie dokie. And then this, we then need to flatten. But it doesn't like that. Oh, return. Because there's going to be a bunch of these, right? So we're going to have like a bunch of arrays. And so we have to then flatten these down into one flat array. And we're missing description. As string. Okay, string, double, string. That looks good to me. So now we essentially have if you look at this signature of this, right, a list of Firestore split data coming out, a completable future, and completable future unit is what's going in. But if we don't return the data, this won't work. So oh, actually, this won't work either. So we can't necessarily update the cache. Well, I guess we can. So part of the issue here is that cache put requires you to return something, and that's what's put in the cache. If I only give it like a subset of the split data, then it's only going to have a subset of the split data in the cache. So that isn't going to fly. So that means I either have to like put all of the split data into the cache, or I have to save it all at once. Or I can't necessarily cache this way. I do something with dividends here. History, recent. Right, I cache it by year and okay. All right, so maybe we will do this just in terms of caching. Yeah, we might as well just go ahead and do this. Okay, so what I'm going to change here is I'm going to add the from year and to year. And then dividend history keygen get. Is it that? And then save. I don't do anything with the cache. Okay. Right. Okay. So this will work. This will work. We just have to be a little tricky here. All right. So here's what we are gonna do. So if someone passes in this, right, we want to cache this information, and we want to cache something like splits underscore from year and to year, and the same or dash, and then the same thing here. And we will simply assume that if you pass in a subset of data, we're only going to save that as a subset of data. Does that work as well? That should work. All right. What we are going to do is the following. So we're basically going to say when params of 1, because we always know params of 0 is the symbol, we're going to do the following. So we're going to look at this and we're going to say if it's an int, create this cache key. And if it's not an int, if it's a list of something, we're going to create a different cache key. So when params1 is int, we know that this is the save method. And when it's list, this is the get method. And this is the save method. Yeah, and it's got to be a list of anything. So then this will be the following. All right, so the easy one, right? The get method. This is going to be, we're going to return symbol dash params 0, params 1. Right? So we have 0, 0, 1, 2. This is going to be 0, 1, 2. Right? So the cache key is going to be the symbol, the from year, and the to year. And then this is, we need to parse out the min and max year from this split data that we get. And then we need to try this out. So we're going to say val splits equals params 1. So we're going to cast that. Again, not the best thing in the world, but we know what we're doing here. And then we need the first year and the last year. So what would we do there? So we're going to say splits dot map it dot xdate dot get year. So now we have a list of years, and we are going to call distinct so that we have a unique list of years. And then basically we want the biggest and the smallest. So we're going to sort. And then we want the first and the last. So this is then going to be $ symbol. And then it's going to be years of first. And then years dot last. And the years could be one and the same, but that is okay. And then we need an else statement, of course. And we'll just throw an exception. We'll say unknown key for splits. And we'll print the params the best we can. Return. We can clean this up, make this more Kotlin friendly. Okay. So this should be good. We will, I'll put a debugger on here when we run it, and I'll show you, we'll take a look and see how this works. So that should do the trick there. Both cacheable and cache put for when we save. So let's give this a try. We do need to wire these two things together, however. So let's go ahead and do that next. So the stock split service is up here in data. Right now, it just has this concept of a client, and then we're also going to ask for Firestore Split. That service. Then I'm going to fix this logger name, even though we don't use it, so we can get rid of that. Okay, so then when we have splits, we're going to want to save this into our database and then our cache. Save symbol. And so here's, again, we have to convert again. So we're going to say to Firestore Splits. And we're going to basically write a similar function as we did for here, but the other direction. Internal fun stock split dot to Firestore Splits. This is going to return a list of Firestore Split data. So this is going to this dot. This doesn't have a symbol, but we can pass it in. And it's effectively just going to be this. So declared date, X date. Yep, all of these guys. Description ratio from factor to factor. Yep, it's going to be that. And then we're going to need another one for a list of. We'll make this singular. This will be plural, and this is going to be a list of our star split data. Okay. So again, little duplication here and there, but I prefer this so that we are going back and forth properly. We're gonna await the results of this. No, we don't need to do that. We can just call splits or just return splits. Now we're not actually checking the cache first, so that's what we're gonna do here. So we're first gonna say Firestore split dot split symbol. And in this case, we're gonna do the maximum. So we're gonna make the maximum that for now, but we're just going to pass in 1900 to local date.now.year. Actually, this is fine. We'll leave this as 1 year. And then if someone passes in a larger value, you're fine. And the question is val splits. If this exists, so if it's not empty, then we're just going to return split data dot to splits. So now we have to write it the other direction. So this is going to be from this to this. And this is going to be this to this. We don't need the symbol in this case. Because we have that data. This is going to be called toSplit. And this is going to be called stock splits. And we don't need the symbol. toSplits. Okay. Same JVM signature as what? Oh, right. We'll call this convert response. But two. Interesting. I wonder why that one doesn't freak out. Oh, it's because it's not an array. It's not an array type, so that's why. All right, so again, this isn't perfect, but this will do for now. If there's anything in the cache, don't update, just return. If there's nothing in the cache, try and put that in the cache. And then return it. All right, let's go ahead and give this a shot. This is already wired up as we did that in the last stream. We have some breakpoints just to confirm this is working. So let's go ahead and give it a shot. Okay. We need our GraphQL client up here. So what we're going to try and do here is run a query. It's going to get 1 year's worth of data, save it in the cache, and then serve it from the cache directly right afterwards. Right. And I need here this. And then we're going to need this as well. Okay. Let's debug this now. Yeah. Okay. So we will do this walk along the way and see what we get. Failed to inject value. Firestore Splits, stock split service. No bean exists. Firestore Splits sure does exist. Oh, that's in notification service. So we want the API service. So this is one of the many benefits of well, benefits and downsides depending on how you look at it of dependency injection is that you usually get quick feedback on if your configuration is not correct. All right, so we're started up. Okay, so if we run this query, we will probably get a Firestore issue of some kind. Oh, that's correct. We need an index. Alrighty. Okay. So this is actually good. Let's. So we're gonna have to create an index, and we're gonna have to use my Terraform stuff. So let's take a look at that. And so this Firestore thing is actually pretty nice. If you try to do a query that requires an index, it will tell you. So we're going to go ahead and add this. Failed to load. Okay. How did I get something wacky in the URL? Probably that. Okay, so what this is telling us is that in order to do this, we have to have a composite index for splits with symbol and year so that we can actually do a query on it. So this is why I have Terraform set up so that we can quickly and easily add these. And then later on, right, I can apply this to production or any of my other environments and we're good. So if we come in here, we just have to add a new index and do this. So splits, symbol, and year, ascending, and then this underscore name is simply something you need. It's kind of required. It's an under the hood thing. So let's go ahead and apply this. In order to do this, I have a bit of a unique setup. So on my computer, I typically don't install a bunch of stuff just because of different projects have different versions, right? And managing all those different versions of things for different projects on my computer is kind of a pain. So I wrote an article about what I do on the website here. And if you take a look at this, right, it goes through everything. But the gist of it is I have a special kind of small little Docker environment. And we're going to spin that up here, get into that shell, do the authorization, and that shell or that container has all the tools in it. And then we'll apply this from there. So let's go ahead and do that. Okay, we are here. So we're gonna run. I have a script that runs this. It's called Devops Shell. All right, so now I'm in the container, right, with all of the tools. And now we can go to work. So gcloud auth application -default log in. It's going to give me a special URL. I'm going to put that into the browser, get the auth going, and then we will run our commands, our Terraform commands. Okay. All right. So we're authenticated. Now we're going to go into our Terraform folder and we're going to say Terraform apply. And it's going to ask me, duplicate resource portfolio indexes. Yep. Splits indexes. So this is going to ask me for a couple of things. I require the commit hash, which is going to be the same as what's already deployed, the project name, and I think that's it. So let me look these up real quick. What is the currently deployed version? And I just have to do this because it like reapplies everything, which in this case is fine. I don't mind. Like it's not gonna redeploy the service. It's gonna go, oh, this is the same, so we don't need to redeploy this. So, so that's the current version. The notification one is the exact same, and the project ID is exdividend.staging, right? So this is gonna look at the diff, right? And it's gonna say, this is different. We need to add a new index, right? So we're going to say yes, apply, and it's going to add this index. And then if we come over and we look at our thing here, right, it's creating our index. So we'll give this a minute or so. Sometimes this does take a little bit, so hopefully this goes quickly, but we'll give this a little bit, and it should do the trick. This is maybe one of the downsides, if you could call it that, of using Firestore, is that sometimes creating indexes can take a while. It's essentially a background job that runs. And even though we have no data, there's some things that are going on clearly to prepare this index. So, which is fine. Still going. Actually, I probably should have checked that. Yeah, the environment was staging. Okay. Yeah, it wouldn't let me done it to production. All right. Indexes are taking a while. All right, well, while this is still going, we'll pull this over here. And I will keep an eye on that. Range 1 year. Let's do this. Let's update our query to take in potentially a larger range, or just take in any range, right? So you can pass in a from year and to year. Dun dun dun. Stock split service. Parameter type query. Right. So right now it just takes a symbol. So let's add from year and to year here. Pass that on through. And then we can continue to pass that as well. Int. So I'll pass this over here. And the range, we're just always going to do 5 year in terms of what we're picking up. At least for now. We'll, I haven't decided. Typically, I don't like to put data fetching in kind of the straight line of fire. I'll probably do this in some sort of job later on, and then this is only going to hit the cache, or it's going to grab 5 years worth. So, okay, so resources are added. That is all done. Okay, so let's try this out. Let's go ahead and rerun this now that we've changed the signatures and the queries. And we'll check this out. Okay, so that's up. This is now going to complain because we added from year and to year. So let's put from year 1990 to year 2021 and run the query. All right, so we'll see split data is empty because we don't have any split data yet. So now we're going to try and go ahead and grab that data, and we're now in our key generator. And so because we are saving, the first param is symbol, second param is this. So we're going to jump into here. And so now what our string is going to look like is this. We can evaluate this here, right? Oops. Edit. So as you can see, our string will look like this, 2020 to 2020. That doesn't look right. Okay. Splits. There's only one item being passed in? That doesn't seem right. I mean, maybe, well, actually, no, that may be right. Maybe Apple is only split in the past. Yeah, so Apple's split was probably further along than that. Okay, so that works. Although we need to find a stock that's split more than once in the past 5 years, which might be a little tricky. But okay, that's fine. So that gets created. It returns splits right there. And then if we hit this again, this is going to hit the cache. Nope. So that means we don't have data in Firestore potentially. So that means our save function maybe didn't work or our query is wrong. So let's look at our data. The data is there, but interesting. It also doesn't have a declared date. Is that true? Let's check the actual response data and see if something is up. Oh, we never actually did this, so let's okay. So 2 problems. One is make sure declare date is coming through. Declared date, that definitely should be coming through. So declared date, X date. All right, so if we check this here, but the real question is why isn't our query working? Greater than or equal to that, less than or equal to this. And as you can see, we definitely have data in here. So why ain't that working? All right, we'll check that in a second. Let's figure out why declared data or the declared date is not coming through. Let's debug that for a second. Oh, there we go. Now it's coming through. Okay, so it was probably just the cache catching, or sorry, the indexing on the database catching up. But in this case, declared date is not coming through, which is bad. And as again, if I run this right, query super fast. So this is coming from the in-memory cache. It's not even hitting Firestore. But we missed declared dates, so we need to fix that. So we're going to comment this out. And we are going to check why that's not coming through. Because it sure says in the documentation that that exists. So I'm wondering what I got wrong. Okay, so if I run this, so this, no, declared date is empty. Huh. Declared date. Okay. That is concerning. Why doesn't that come back? All right, so we need to do new client. Let's add the logger so that we can see the full request coming back and see what's going on. Okay. All right. Splits. Here is the info. being returned. Declared date is null. Okay. So that is a nullable field, I guess. And it's not always going to be there. All right. So remove the logger. And this, we're just going to mark that as empty. Which is annoying, but that is what it is. Right? I didn't miss anything in there. Yeah, no, it's not in there. Declared date is null. Okay. I guess, I don't know why they wouldn't always have that, but I guess they don't. The data isn't perfect from any of the data providers, so at least we know. All right. So this is working the way that it should. Let's see if we can find a stock that's split twice in the past year. Just to test because I kind of want to test. Each of the 7. None has split for at least 5 years, but all have split at least twice in the past 25 years. Okay. So it doesn't look like it's going to be easy to find a company that's split twice in the past 5 years. But that is not the worst thing in the world. We can probably rewrite this code so that it actually is a testable function. So let's do this. We will write an extension function again. An internal one so it doesn't leak out everywhere. So we're going to call this years. This is going to return a list of ints. And this is just going to be this, right? Just to make sure that this is working the way that we want. Splits.years. So then we can test this function to make sure it's doing exactly what we want. But of course I don't have the test set up in here, but let's just go ahead and do this. Okay, so we're gonna do all right, Firestore Splits. Okay, symbol doesn't really matter. Declared date doesn't matter. X date does matter. So this is going to be, let's call this 2020 0101. Ratio doesn't matter. Description doesn't matter. From factor and to factor don't matter either. All right, so we'll need to put a couple of things in here. we'll put a couple of entries in here, right, with different years so that we can make sure that we get the right things. And we're going to put them out of order as well. So that everything looks good. So really what we're doing in our function down here, right, is doing something like this. So we don't have this symbol, but this will be this for our test purposes. And we'll go ahead and run this function. It's relatively simple, but I just want to make sure that this is doing exactly what I expect it to. So it's basically grabbing all the years. So years is going to be 15, 18, 19, 20. And then basically first to last, right? So, and this is also going to be from to to, right? So you're going to, query for, the lower year to the higher year, which gives us what we want. And then that's going to print the string Apple 2015 to 2020. Yeah, so that works. Good to just verify that. I don't have the JUnit testing stuff in this module. Most of my testing happens up in the higher level things, so I'm not going to bring that in for this because it's pretty straightforward. But that looks pretty good to me. All right, that took a little while longer than I thought, so I think I'm gonna call it quits for now. But it's good that I got the caching in there. Then I guess in the next stream we can focus on the dividend return math. And then I think we'll actually be able to pull this all the way through and maybe release the final big feature over the weekend, which would be cool. So actually, let's just make sure this works one more time here. Make sure we didn't miss anything. It's not empty. Return this. All right. So again, if we're starting this up, it's going to go to Firestore, cache it. So it's never going to hit down here. It's not going to hit our breakpoint. Well, it's not going to hit our breakpoint anyways because we're running it, not debugging it. So let's debug it. So if we do this, it'll take a second because it's got to go to Firestore, but then it's right in the cache, right? So this function right here returns super fast, doesn't actually end up going to Firestore, right? Because the data was returned and it's held in memory. So it's much faster. Which is what we want. We always want things to be fast. So I think that's it for this stream. We will pick up where we left off in the next stream, finish the dividend returns work, and then start pulling all this plumbing through to the front end on the iOS app. So that's about it for tonight. Again, if you got any questions, let me know. And we'll catch you in the next stream.